Okay, what is visual language? What is visual language? Before getting into visual language, let's take a look at just programming language, okay? Non-visual language. I mean programming language. Okay, very simple, very simple thing, okay? There is a set, there is an array, sequence of numbers 6, 7, 8, 9, okay? There is a set, and its variable name is A. And B is a static number 5. Result R is an array of A minus B, which means 6 minus 5, 1, 7 minus 5, 2, 8 minus 5, 3, and 9 minus 5. Actually, it's wrong, okay? So this one, of course, 4, okay? Okay, this is the algorithm, okay, approach, the definition of a simple operation. So how to implement this one in computer programming language? Just for your information, let me show you very easy to use language, okay? I made this language, actually program using Java. This is Java interface, okay? You don't need to know programming, but I like to bring your attention using this Java application. Okay, let's take a look this program code. There is main class, which is runnable, okay? Public static void main, and there is a to list, integer value list, and list 2. List add 6, 7, 8, 9, okay, as a value, and for loop while list value ended. So my func is here. My func determines given value minus static number 5, okay? So new list 2 gonna be added like this, operated, okay? 6, 7, 8, 9 added, and operation A minus B applied, and new list stored, and the last command is here, system out print line, which means display the result. Okay, let me execute this program. Okay, 1, 2, 3, 4. That's the result, okay? Take a look, this program code. Even if it's just 25 lines, what if very complicated geometric controls? Probably really outreached, very complicated. So my point here is computer programming is complicated, and you are very far from computer programming. That's the problem. So someone who's wanna take some very skilled experts design knowledge or parametric design, but not that good at programming. There is an intermediate way, okay? Visual language. So let's take a look at this node. Actually, this one is node or battery, okay? Take a look. What is the visual notation? What this visual notation means? Two parts, left side, right side. Usually left side are input values, right side are output values. And this battery simply determines minus operation, okay? So take a look. A has array 6, 7, 8. At this time it's 12, okay? And B static number 5. So A minus B simply returns this array collection 1, 2, 3, 7, okay? So this function, this battery simply determines input values, its operation as well as output, okay? Very intuitive, very easy. How about this one? In this case, it's looking a little bit different and difficult, but because of this one, fx, okay? Fx usually means function. Function means specific operator, equation. What is this operation in this case? Take a look. Left side, of course, there is x and y value. Another one, f definition. F definition at this time, the same one, x minus y. So this one is x, y is static. So output result, same. What if you change the function x multiply y? And then what is this one? 30, 35, 40, and 60, right? So you can also change y minus x or x plus y. How about cosine x multiply y? That's a new type of definition. Why we need to use cosine or sine? As you know, cosine and sine has curve. Okay, so very easy way to get curve in this kind of definition. We're gonna make sine definition today. Anyway, very intuitive visual language compared to this programming language. Okay, that is the power of visual language. Okay, so this is very simple. What if you have very complicated visual language? Anyway, anyhow, they all have specific algorithm, procedure, and input-output values. Okay. Representatively, there is grasshopper. Okay, you may be heard about grasshopper a lot, and you may think, should I learn grasshopper or should I need to use grasshopper? I think you don't. Okay, you need to learn Dynamo. Similar one, but it's on top of rabbit. This one is on top of rhino, which means geometry. Okay, this is really popular and famous. Lots of architects, designers are currently using grasshopper, but it's anyway rhino plugin. If you learn Dynamo, you can learn grasshopper easily, quickly. Okay, so that is why I like to encourage you learning Dynamo, not grasshopper. Anyway, as a representative visual language-based design approach, let's quickly look at how it works. Okay, let's take a look at today's example. Actually, if you want to learn grasshopper, Dynamo, any type of visual languages, there are a bunch of tutorials, videos, references. But the most important thing is you need a plan. Okay, you need an algorithm to represent something like this. What if you want to create something like this one in 3D Max? Just simply clicking mouse. Okay, because 3D Max is designed by mouse clicks. Okay, a tool for design by mouse clicks. But if you want to define this one in mathematical way using numbers, so-called design by numbers, you need a specific algorithm. At this time, draw some sine curve-based lines, sequence 3 or 4 lines, and convert them into arrays and some solid fields and so on. Some procedural approach to define this geometry. So let's take a look. This kind of, we're going to make something like this one using Dynamo, not this one. But anyway, take a look. This is series, so-called collection, array, sequence in Dynamo, okay? The same concept. So take a look. Start going to be 0. You can put this number. Step. Step means step, okay? The next value minus the former value going to be the step, okay? Count is total number of iteration. So count 12, which means integer I number 0 to 11, total 12. Step 5, starting 0, that is why that one is 0, 5, 10 until 55, okay? So this is the output of this node. So where to use this one? Value for x, value for y, value for z, and so on, okay? even more values, or number of points, or location of points, location of lines, and so on. Okay, anyway, defining the sequence of the numbers using cosine, sine, and some different variation numbers, all they are cosine, sine curve. Thanks to them, you can generate the sequential points like this way, okay? The sequence of points. And there should be, okay, take a look. This is point, okay? Point definition for each point. But there is, of course, the definition for curve line, polyline, and the definition for surface. So series of, okay, Antoine, you don't need to know that right now. Flip and curve definition. Curve definition generates this kind of connected curve line. And some operation for making extrude surface, sweeping. You know the sweeping, extrude, followed by pass. So all they are pass definition, and what you need to define is rectangle shape, section profile. And then it's going to create this kind of this kind of swept solid, exactly followed by that sine, cosine curve, okay? That is why you can get this one, and you can export ACES, SAT file, import in Revit. That is why we could import this SAT file in your Revit interface. There are a bunch of useful Rhino and Grasshopper tutorials, and some additional tools to support BIM, to support Revit. So if you are interested in this kind of approach, there are comparatively many and rich of references you can take, okay? Okay, at the end, at last, we just reached to Dynamo, okay? This is Revit plugin. Dynamo is Revit plugin. Visual language-based design approach, okay? Simply, this is BIM, okay? This is BIM. Actually, we're gonna create a specific geometry. For example, we're gonna create this kind of geometry right now. But before moving to the lecture slide, let's create one part of this geometry using Dynamo. Let me tell you fundamental mechanism and approach of Dynamo, okay, before moving to the lab exercise. Okay, please open Dynamo first, okay? And you have to create new. I like to introduce you very fundamental interface of Dynamo in order to create something, okay? Okay, this is empty, blank window when you get started from Dynamo, okay? As you see, this is kind of background geometric world in 3D. So click this button, okay? And then you can zoom in and out. Click right button to rotate. Something different interface, but anyway, right button, okay? Right button to orbit, zoom in and out, wheel button. Click this one again. You cannot zoom in and out or rotating. But anyway, currently there is nothing. Okay, simply click right button. And let's type point, okay? If you type point, there are a bunch of point-related nodes. So the first one is point by coordinates. Coordinate simply means X, Y, Z coordinate system. So enter. Okay, it's too small, so zoom in, okay? Let's zoom in. Now you just created a point dot by coordinates, okay? And let's take a look at what happened. Actually, it's not easy to recognize, but anyway, there is a point. Okay, there is a point. So let's click Y and you can drag something. But how to assign numbers X, Y, Z? So let's click right button again and let's type number. There is a number, okay? And you can change the value. How about number 4? Okay? X, Y, Z, number 4. And how about click right button again and number? Also, how about 5? And at this time, click right button, click right button and number slider. Take a look, this one, number slider. Okay? At this time, let's place number slider. Okay? What is number slider? Actually, default value is 1. But by using this slider, you can change the value like this. Okay? But let's click this one first. And then you can find out minimum value. Minimum value you can change to 1. Maximum 100. That's fine. Step. How about step 5? In that case, let's change. 1, 6, 11, 16, 21, step 5 until 100 from the 1, okay? So you can change numbers. Also, you can change numbers by those things. Okay, this one, what if you want to make this one to X? Click X, okay? So now you see the point is here, okay? Simply because current value is 36. So let me change the value to 11. So now this one moved to 11. Okay? Okay, let's drag this one to Y. So now Y is 5, and the Z going to be 4. Okay, where is it? It's not easy to see, so click this one, and let's take a look. The location of that red dot, okay? The location of red dot. That one is exactly same to the definition X 11, Y 5, Z 4, okay? According to X, Y, Z coordinate system. And you can also control easily by this slider for X, okay? And Y. Okay. Actually, this is not that funny, so let's create something interesting thing using sequence, okay? Okay, how to remove this location link? Simply drag and click somewhere like this, okay? At this time, let's create a new one. I mean, sequence. Click right button and type SEQ, and then now you can see sequence. Sequence means array. So double click sequence and take a look. Start, amount, step. Okay. So how about start using number? So number. Click right button and number. And number 0 going to be start. Okay. How about amount or step? Okay, let's define step first using number. Okay, you can easily copy and paste number. Select number, Ctrl C and Ctrl V. There is another number. And step going to be 3, 4, 5, whatever, okay? Number going to be your step. And amount. At this time, let's use number slider, okay? Number slider. Number slider, definition, step number 1, minimum number 1, maximum 100. So this one can be amount. And default 55, 41, whatever it is. Okay, let's take a look. what if this sequence, okay, take a look, mouse over here and click this one. Click this icon and then you can find out the final value here. Let's move slider. If you change slider to 8, number 0 to 7, which means total 8 number of things, from starting from 0, step going to be 5, that is why 0, 5, 10, 15, 20, until 8th number, okay? This is the output of this sequence, okay? So what if you change the slider to 20? So total 20 numbers defined like this. Okay, click this one in order to hide in automation. So let's use this one for X. So what happened? How about using this one to Y, this one to Z? And then click this one or Control B, and then you can rotate and take a look behind the geometry. Okay. Now this one currently not used. Okay. So let me delete Y and let me assign this one to Y. Okay, in order to change Y value like this. So do you figure out what just happened on this screen? Okay, take a look. This is point by coordinates. Okay, the definition of points. Please roll over the mouse and take a look the list. Okay, amount of points, point X and X, Y, Z coordinate system numbers defined under this list. Take a look. Z value is always the same. What if you change this number from 5 to 10? This one going to be moved to Z direction to 10. Okay? Take a look. Y value. Currently it's 21. That is why always Y value 21. How about X? X is something sequence, something changed. Okay? Why it changed? It's a sequence number, okay? Like this. 0, 5, 10, 15, 12 using step count. Later on, we're going to use sine, cosine equation in order to make this one curve. But right now, this is point, okay? Actually, this is very fundamental and very critical approach when you are using this kind of visual language. Okay, series of dots defined by numbers, your equations, your programming, your languages, your algorithm. Okay. Anything very complicated geometry, control over geometry, you can define. Even if this one is looking very complicated, always it has input and output. So now this output is never used. So how to use these points? There is a node which is creating polyline using points. Okay. That node left side input is points. So simply drag and drop this point to that one input. And then now you see the connected line. Okay. So how to use that line? Using sweeping, pass, whatever, in order to create geometry. And then your final geometry will be easily and intuitively created. Okay, we're going to keep using this one for creating this surface, this kind of surface in the lab exercise. Not right now. Let's go back to the course material, okay? So save this file or just leave that window. Don't close, okay? Okay, let's quickly look at Dynamo. Dynamo, some background parts. as a Revit plugin, as one of the BIM application, this is really powerful. Open source graphical programming for design. That's what they said from their website. For your information, let's open the website and let me play the movie. Their advertisement movie, actually something about structural, roof structural elements. So let's click the video and okay. Let's take a look at this video briefly, okay? There is Manhattan, Hudson Yard. This is a design approach, okay? By using Revit, this is dummy geometry of Manhattan. This is their design site. So this is elevation. Here is their concept design, okay? Something like this structure. Let's create this structure using BIM, Dynamo. So let's take a look at Dynamo nodes. They are looking very complicated, but manageable. You can do that. So watch this video, okay? The one single elevation structure can be copied in X direction, Y direction, recursively in order to control slab and the rooftop structure and some details and so on. Entirely managed by BIM application, Revit, okay? Dynamo is a Revit plugin. So if you install Dynamo, you can find out Dynamo button in Revit on the plugin add-on tab, okay? Anyway, according to this video, you can find out the initial design approach, controllable approach can be managed by Dynamo and Revit in this way. Why we need to use this kind of BIM application? Why I'm saying not Grasshopper? Why I said learning Dynamo? This is BIM tool, which means you can control quantity, takeoff, and information and schedule file, something like that. Amount of powerful additions and expansions, something like this, using Grasshopper as well as Revit's powerful features, okay? So let me quickly move and you can take a look some detailed parts. Controllable geometry. Also today's one of the lab exercise issues is another one, curtain wall panel. Today's curtain wall panel is going to be cutting a hole panel. I'm going to show you that lab exercise. Even that one also controllable by this kind of plugin language, Dynamo. Also some color code added and some deep color variation can be applied for using this kind of Excel spreadsheet definition. Start and value color. Output color can be assigned to list. List means some array components defined in this structure and some other colors. There are a bunch of visualization, differentiation, and okay, take a look. The final, this is not room schedule. You remember the room schedule, but at this time, roof structure schedule, okay? Roof structure schedule exported in that way. So at the end, even if it's conceptual anyway, BIM supported design created like this way. Thanks to Autodesk Dynamo team as well as ModeLab, okay? This is official video from Dynamo website. Okay, Dynamo is the new way of handling geometries of Autodesk Revit, okay? Why we need to use such visual language? Two versions, Dynamo Revit plugin and standalone version, but actually you don't need to use standalone. Dynamo Revit version also runnable by itself, okay, as a standalone version and totally free. Anyway, now you have Dynamo installed, which means your Revit has Dynamo plugin, okay? Simply download even in Autodesk student website. and some features, lots of tutorial, amount of useful references, video files, and so on. Why we need to use this kind of tool? Even if it's looking complicated, rapid iteration. Okay, iteration couldn't be done by human. If you are working for same task, same 10-minute task, never ending, 10-minute task again and again, we're gonna die, okay? We cannot duplicate our tasks again and again. But computers can do that until end of the world, okay? That is the reason why we are using computers. Computer never, how can I say it? Dislikes or disappointed from iterative and recursive, never-ending tasks. Anyway, something different changed, some changes, some different modifiers, different parameters, different numbers can be applicable. But anyway, same mechanism, but totally different iteration in order to create totally different geometric shapes. What if you have to create one by one? You have to create one by one, but by using this kind of tool, language, you can make very iterative and recursive way, in very convenient way. Broad interoperability. This geometry can be exported to 3D Max, SketchUp, AutoCAD, Inventor, Rhino, any other tools when you bake, when you finalize the geometry, okay? But in Revit, you can finalize the geometry, but anyway, you still have control using Dynamo, okay? Visual logic, which means anyhow, anything, whatever it is, your definition, okay? According to your definition, final output can be defined. So, you know, it's logical definition. So if you change logical definition or equations or variable numbers, you can make any other type of variations. And also this one, the power of this one is it supports scripting language. Behind of this visual language, there is code block and computer code. Very similar to processing language or Java code that I show you today. Take a look. Radian multiply mass dot cosine sequence value. This one is exactly same thing that you created before using sequence node, okay? Behind of the sequence, you can find out this one and some iteration. If you understand this code, at the end, you can develop Revit plugin. The language used here is C#. C# language is one of the .NET language, very commonly used nowadays. And then you can use this one, this language for developing Revit plugin, okay? Very powerful. And scripting interface can be applicable for managing, updating your geometry. Amount of learning features in Dynamo website, as well as some general Dynamo or BIM community websites. These are all video tutorial. Very intuitive, easy to use comparatively, okay? Okay, in today's lab exercise, we are going to create the geometry, this one, okay? Rest of the geometry creation, and move on to the next issues. At last, let me show you this one, Revit interface. In Revit, okay, in this Revit interface, there is add-ins tab, and now there is the button Dynamo, okay? On the add-ins, there is Dynamo. So if you open Dynamo from this interface, your geometry will be embedded into Revit project or Revit family editor, okay? But if you open Dynamo without Revit, That's going to be Dynamo file, Dynamo project. Okay, let's quickly have another 10-minute break and move on. Okay, rest of the lab exercise and live demo.